All right, today we're going to tackle a concept that is absolutely fundamental to object-oriented programming, Java inheritance. Think of it as the secret to building really powerful, organized, and super efficient code by creating blueprints you can use over and over again.
Let's start with a simple question, right? If you already have a blueprint for a basic vehicle, it's got wheels, an engine, a frame, why on earth would you start completely from scratch to design a car, or a truck, or a motorcycle? It's just a massive waste of time and effort. And in the world of programming, this is the exact problem inheritance was born to solve. And here it is, the elegant solution. Inheritance is this amazing mechanism that lets us take an existing blueprint, what we call a parent class, and create a new, more specialized child class from it. The cool part? This new class automatically gets all the features, all the good stuff from the parent. The bottom line is simple. Don't reinvent the wheel. We're all about reusing what works and then building on top of it. So to really get a solid grip on this, we're going to walk through 5 key areas. We'll kick things off with the family tree of code to see how these relationships work. Then, we'll look at the different shapes these family trees can take. We'll also dive into a famous programming puzzle called the Dimal problem. After that, we'll cover the essential rules of the family. And finally, we'll tie it all together and see how this stuff works in a real-world project. Okay, first up, let's really dig into this idea of a family tree for our code. In Java, you'll hear the terms superclass for the parent and subclass for the child. It's all about creating a really clear line of descent. Now, the absolute heart of inheritance is what we call the is-a relationship. This is the golden rule. It has to make logical sense. You can say a car is a type of vehicle. That works. A dog is an animal. Yep, that works too. This simple little test is the foundation. If that is-a relationship holds up, chances are inheritance is the right tool for the job. So how do we actually create this family bond in our code? Well, it's with one simple, powerful keyword, extends. We define our vehicle class, and then we just say class car extends vehicle. And boom, instantly our car class has everything a vehicle has, all its properties, all its behaviors, without us having to write a single extra line of code inside it. It really is that powerful.
And here's a really cool piece of Java trivia that's actually super important. Whether you realize it or not, every single class you ever create is already part of one giant family tree. See, if you don't explicitly extend another class, Java does it for you behind the scenes. It makes your class a child of the ultimate parent, the object class. That's the universal grandparent of all Java classes. And that's exactly why every object you create has access to standard methods like toString or equals. You get them for free, inherited from the very top of the family tree.
Now, just like real family trees, these code relationships can form all sorts of different structures. So let's take a look at the main types that Java supports, because they help us model the world in really organized ways. The most common and straightforward one is single inheritance. It's just a direct, one-to-one parent and child relationship. One child class inherits from exactly one parent class. Our car extends vehicle example, that's a perfect picture of this clean, simple structure. Next up, we've got multi-level inheritance. The best way to think about this is like a lineage, right? A chain of generations. An electric car extends a car, which in turn extends a vehicle. What that means is the electric car gets all the features from the car and all the features from the vehicle. The traits just get passed down through the generations. And finally, there's hierarchical inheritance. This is where one parent blueprint is the foundation for a bunch of different child classes. So that same vehicle blueprint we have can be used to create both a car and a bike. They're like siblings, totally distinct children, but they share the exact same parent. Okay, now for a little bit of drama. We've seen the kinds of family trees Java lets us build, but there's one specific type that it absolutely forbids, and for a very, very good reason. This brings us to the infamous diamond problem. So, the forbidden structure is called multiple inheritance. This is where one class tries to inherit from 2 or more parent classes at the same time. You end up with this diamond shape in your diagram, with a child class at the bottom trying to pull features from 2 different parents above it. And as you might guess, this can create a major conflict. And here is the million-dollar question. Just imagine both parent classes, B and C, have a method with the exact same name, say a drive method. When the child class D tries to inherit from both of them, which version of driving is it supposed to use? The one from B or the one from C? There's no way to know. The compiler is totally stumped. It's completely ambiguous. So, to avoid this whole mess, the designers of Java made a very clear and deliberate choice. Java simply does not support multiple inheritance with classes. Period. It's a design decision that prioritizes clarity and predictable code over anything else. It keeps the family tree from getting tangled up in knots. So we've got our family structures, and we've got a huge rule about what's not allowed. Now let's look at the tools we have at our disposal to actually manage and control these family relationships using some very specific keywords. First up is the final keyword. This basically acts like a big stop sign. If you declare a final class, like Java's built-in string class, it means nobody can extend it. Its lineage ends right there. Now, a final method is a little different. It can be inherited, but it cannot be overridden, which means the child class can't create its own custom version of that method. It effectively locks in that specific behavior for good. Next, we have the super keyword. You can think of this as the child's direct phone line to its immediate parent. It's mainly used for two things. First, to call the parent's constructor, that's its setup method, using super, parentheses. This makes sure the object is built correctly from the ground up. And second, you use it to access a method from the parent, which is super useful if the child has its own version with the same name. It's how you say, hey, for this one time, I don't want my version, I want my parent's version.
Finally, let's talk about controlling what a child class can actually see and use from its parent. Public members? Well, they're visible to everyone. No secrets there. Private members, on the other hand, are the parent's deep, dark secrets, completely hidden from the child. But the real key player for inheritance is protected. A protected member is kind of like a family secret. It's visible to all of its children, even if they live in a different package or neighborhood of your code, but it's hidden from the rest of the world. It was designed specifically for this family relationship.
All right, we have covered a lot of theory, the different types, the rules. Now let's see how this all clicks together to build something really practical, like a product catalog for an e-commerce website.
Okay, let's build this hierarchy. We'll start with a generic product class at the top. It has properties that everything we sell has in common, a product ID, a name, and a price. Simple enough. From there, we create a more specific child class, electronics, which extends product and adds a new property, warranty period. And finally, we can get even more specialized with a smartphone class, which extends electronics and adds its operating system. See, this is a perfect real-world example of multi-level inheritance in action. And here is the beautiful payoff. Our smartphone class automatically gets the ID, name, and price from the product class, and it gets the warranty from the electronics class, all for free. We didn't have to write any of that code twice. We define those features just once at the right level. This is exactly what makes our code so much more organized, way easier to maintain, and incredibly efficient. So, as we've seen, inheritance is an incredibly powerful tool for creating those is-a relationships and reusing code like a pro. It helps us build really complex systems in a logical, step-by-step way. But that leads me to one last question for you to chew on. Just because you can use inheritance, does that mean you always should? It's a fantastic tool for sure, but as you continue your programming journey, you'll discover it's not the only tool in the toolbox.